All right, so we're going to try to finish up that addition and subtraction. This time we're going to do, I had you do 1 to 22, right? So 23 to whatever. What's the end of that? What's the last one? So 23 to what? What's the last one? Just tell me the last one. Who's got the worksheet? You should have the worksheet right in front of you. I said we're going to go over it. What is it? 28 to 28. 23 to 28. Is 28 the very last one? No, it's not. It's 32. I know. We haven't done up to 32. So 23 to 32. That's what we're doing. So let's do the decimals. Let's do the decimals right now. All right. So 23. What? Why do you keep saying your mom? Why do you keep saying that? I don't understand that. But why do you keep saying that? Yeah, why do you say that? Oh, it's like I'm swearing on my mom kind of thing? Is that what you're saying?
You know how you say on God?
No.
But I think I said it right. Like, I swear on my mom that, okay, that kind of thing. All right, I was wondering what you're doing. What's that? I'm talking about in general. I haven't gone over 23 to 32. I'm not saying you specifically. I'm talking to the whole class. All right? All right, let's take a look at 23. So it looks like this. It looks like 6 minus 3.98. I'm going to show the old-fashioned way of doing it. Everybody look up here. Everybody should be paying attention now. Okay? We spent like the last 10 minutes passing papers back and talking and all that kind of stuff. Now's my time. Everybody needs to face forward. Okay? You look like you're getting ready to turn around again. Come on. Face forward. All right, so if I wanted to do this with no calculators, because I very well could say, this quiz, you cannot use a calculator. I haven't decided yet, but I could. All right, so you need to know how to do it without a calculator. Everybody watch. So this is written across. If I was going to do this subtraction, I would do it up and down. So since this has 2 decimal places, I'm going to make that 6 with 2 decimal places. Now what am I going to put there? Put zeros, right? Okay, that's the same thing as 6. Agreed? What's going on? Okay, let's pay attention. Come on. Don't distract me. Because I have a feeling that most of you are going to struggle with this if you're not watching. So it's minus what? 3.98. Make sure you line up the place values. Remember that from, I don't know, elementary school, early middle school. You learn how to subtract and add decimals, okay? So you line up the decimal places right here. So the 3 goes under the 6, and the 9 and the 8 go under those zeros. So now what we're going to do is we're going to actually subtract. Can I go 0 minus 8? Nope. I can't go 0 minus 9, so what do? I go all the way to here, and what do I do with that? I take 1 off of there, so I cross that out. I borrow. Remember that? I borrow. And then where am I going to put it? To this first 0. All right. What am I going to put here, though? I'm going to put a 1, which makes it a 10, correct? All right, so I took 1 out of here, and I put it onto here. All right, I'm just borrowing from 1, putting it to another one. All right, but still, I still got to go 0 minus 8. So what am I going to do here? Now I'm going to borrow from this 10, right? I borrowed from this 6. Now I borrow from the 10 and make it a what? A 9, and then I'll put the 1 here. Now I can actually subtract. Okay, what's that? 2 dots? Oh, the number 2? Yeah.
I thought above the 8, I thought that was the 9.
No, because I had to borrow from this, but there's nothing to borrow from here because that's a 0. So I have to go to the next one over. All right? I got to keep on going over. If I have a bunch of zeros, I got to keep going until there's a number I can actually borrow 1 from. Can't borrow 1 from a 0 because the 0 doesn't have anything, right? So I borrow 1 from this one, which makes the 1 just to the right of it, right? I put the 1 there. I borrow from that one. It becomes a 9, and then I've got this. So now I've got 10 minus 8, which is 2. Now I've got a 9 minus 9, which is 0. Put a decimal, and then 5 minus 3 is 2. And that is how you do it. 2.02. That's supposed to be a decimal. It looks kind of weird, but that's a decimal. Yes, sir. Do you have to do what? If you can't use a calculator, I mean, you can do that in your head. On the ones in your front, no. If it's like 3 plus 5, okay, there's no work to show for that, all right? And if it's like negative 2 plus 7, there's really no work to show for that. It's just 5, okay? But for stuff like this, yeah, you absolutely need to show your work. But you're right, there are some at the front, at the very beginning, that there's no work to really show. Now, if you have something like this, watch. What if you have 2 plus 3 minus 1? Now, you could do this in your head, but you know what I would do to show my work? What would you do? Yeah, you could put parentheses if you wanted to, or I could just do what? Do it in your head. 2 plus 3 is what? 5. Put the 5 down, okay? And then minus 1. Now, you can't really show any work after 5 minus 1. You just write what? Just write 4, okay? So you could do it like that. That's one way to show work. But if it's just 2 plus 3, yeah, there's no work to show. Question?
You put 2.2
No, 2.2 is not the same thing. 2.2 is not the same answer. Completely different answer. Right? 2.02 is smaller than 2.2. All right? So that's the only acceptable answer right there. Let's do another one. Let's do 24. I'm not going to do all of these. So 5.8 plus negative 2.5. We're going to have to remember our rules for different signs, right? You're adding. This is positive. This is negative. Remember the lesson I had when I listed all the rules? Okay, we had a rule for different signs. What does the rule for different signs say when you're adding numbers together and they have different signs? What do you do with those two numbers? Subtract, very good, and take what? The sign of the larger number. So basically, this is just a subtraction problem, isn't it? So really, this problem just boils down to this. Isn't that the same exact thing? Right? We just subtract and take the sign of the larger number. The larger number is 5.8. It's positive, so our answer is just going to be positive. This is easier than the first one we did. Easier than 23. So now, everything's lined up. Okay, all my decimals are lined up. So now I just go 8 minus 5, which is 3. Put the decimal there. And then 5 minus 2 is 3. That's your answer. As simple as that. What about 25? So it's 1.8 minus, then they put a parentheses, and they put negative 3.7. What's the rule for this? It's subtraction, right? So what is the rule for subtraction that we did when we learned? Add the opposite. Very good. All right, so what am I going to do is take that minus, make it a plus, and then take the opposite of this. What's the opposite of that? It's positive. See that? When you have two negatives next to each other, it just becomes positive. We good? Now, what do we have to do? We got to add them up, right? So let's say we don't have a calculator, or I don't let you use a calculator. You got to add them up. Make sure you line the decimals up. Okay, make sure the 8 and the 7 or the 8's above the 7 and the 1's above the 3 because the decimals line up. Right? And now you can add. 8 and 7 is 15. Now what do we do with that 1 though? Right, we carry it, right? Is that what they call it? I haven't taught like regular addition and subtraction with decimals in ages, so I forget the wordage sometimes. Just carry it over, I think is what they say. So that would be a what? A 1, 5. Okay, because you can't put a 15 here because that 1 goes in the 1's place. So you put it over top of this. Now you just add those up. 1 and 1 is 2, and 3 is 5. And then don't forget what? The decimal right there. And it's positive because this is positive, right? If I add the opposite, everything's positive, so my answer stays positive. All right. I don't want to give it all away. I've done like half of those. So you got 3 more to do. You got 26, 27, and 28. I'll let you do those on your own. Let's skip down to 29. Now we're going to do fractions. So here's 29. It's negative 3 over 2. They put this in parentheses, but you don't really need it in parentheses. Over 8 over 5 equals. Now, when you were in elementary school, early middle school, they probably did fractions up and down, didn't they? All right. So if you want to look at it up and down, you can. But I'm going to tell you right now, you're going to want to get away from that because when you start doing addition with fractions and you have algebra stuff in here, because eventually we're going to have some variables in here, right? You're going to have variables on the bottom. You'll have variables on the top. What do I mean by variables? What is it? Letters. That's right. Okay, letters. You have letters in here, okay? So doing them up and down like this, I don't know, does this look a little more familiar to you? Or does this? I don't know. So you could do it this way. Let's do it both ways, all right, just to show you. I don't know how you were taught this. I don't even know how they're teaching it today in elementary and middle school. I guess you did fractions in elementary, didn't you? Maybe 4th grade, 5th grade, something like that. You probably did fractions. Yes? No? Anybody remember? You're a lot closer to 4th grade than I was, because 4th grade was a long time ago for me. So I don't know. 4th grade, that's like 50 years ago for me. 50 years. Can you imagine? Do you ever think you're going to be that old, or you say 50 years ago I did this? You'd probably think you're in a nursing home or something. Well, I'm getting close to it. All right, what do we got to find? When you add fractions, what do you have to do? Find a what? Find a common denominator. That's right, okay? On these, the common denominator is pretty easy, because really, I mean, every single time if you want to, you could always just multiply the denominators together to get a common denominator, all right? You don't always have to do that, but in this situation, it looks like, yeah, number 30, you don't really have to multiply them together. But anyway, what number does 5 and 2 divide into evenly? What is it? It's 10, right? So I put a 10 here and a 10 here. Now I'm going to show you something that some teachers probably skip over. They might show it to you, I don't know. So what did you do to that 2 to get to 10? Multiplied it by 5, okay? So I'm going to put a dot instead of a times x, okay, for times. Put a dot. So you had to multiply this by 5. Everybody see that? 2 times 5 is 10. Now, we got to do something to the top. So what do we do to the top? We also multiply it by 5, okay? Now, the rule is not really whatever you do to the bottom, you do to the top. I don't normally do this, but something came up on my YouTube feed, and it was this teacher teaching math. I thought, I wonder how she teaches this stuff. It was some of the same kind of stuff that I was teaching in another class. And I was like, I wonder how she explains it. So I was watching, and she did a really good job. I mean, I think I even subscribed to her because it was a really good job of teaching. I thought every once in a while, I'll take a topic, I'll see how somebody else presents it, and then, I could probably use that too. And she actually did something. She did this factoring thing where I had never seen that before. And I was like, that's a cool idea. I think I might use that the next time I teach factoring. So anyway, I was watching this lady's video, but she said, whatever you do to the bottom, you do to the top. That's not necessarily true, okay? Now, whatever you multiply the bottom by, you got to multiply the top by the same thing. The question is why? Why can you multiply something on the bottom and multiply something on the top by the same thing? Why can you do that? Well, it's not because it's going to be even, because what is this? I put it in yellow for a reason. What does 5 over 5 equal to? Give me a number. 1. It's the number 1, okay? And what is that 1 doing to that negative 3 over 2? It's being what? Multiplied, okay? What happens when I take any number in the world and I multiply it by 1? Okay, it's going to be the same thing, okay? Everybody understand that? Okay, so really, why can I multiply by 5 over 5? Because I'm multiplying by 1 and it doesn't change the value of it at all. Do you see that? That's why I can do it. A lot of people skip that. A lot of teachers kind of skip that reasoning. I think it's important to know. So 2 times 5 is 10, negative 3 times 5. Now, it's weird that they did this because we haven't learned how to multiply negative numbers yet. We're going to later today. All right, that's that next worksheet. But this is good practice. What's 3 times 5? It's 15. And if you have different signs, this is what I'm going to teach in a few minutes, okay? If you have different signs, your answer is always negative, okay? So it's negative 15 over 10. That's the exact same thing as negative 3 over 2. It's the exact same number. It's just this one is simplified and this one is everything times 5. What about the bottom? What about this thing right here? What did we multiply 5 by in order to get to 10? Multiplied by 2. So I multiply that by 2. What do I do to the top? Multiply that by 2. Why? Why can I do that? Because all I'm doing is multiplying by a what? Come on, we just said it earlier. Think of what I just did before. What did I say 5 over 5 was? 1. What's 2 over 2? It's 1. What's anything over itself? What's 173 divided by 173? It's 1. Everybody got it? So anything over itself is what? 1. So what am I doing to that 8/5? All I'm doing is multiplying by a 1. It will be. But what's 8/5 times 1? It's still 8/5, right? We're just going to write it a little different so we have a common denominator. So that's why. That's the why we multiply by 2 over 2. So 5 times 2 is 10. 8 times 2 is what? 16. And then we're almost done. So since we have a common denominator, we just keep the denominator the same. We don't subtract the denominators. We don't add the denominators. We just keep it the same. And what we do is we add or subtract the numerators. So I've got a negative 15 plus a what? A 16. So what is that? It's positive 1. All right? Remember, if they're different signs, we subtract the two numbers, take the sign of the larger number. So I subtract them, and I get a 1. 16 is bigger, so I keep it positive. So that's my answer right there. Now, what I'm going to start doing is I'm not going to do them up and down like this, all right, because of what we're going to do a little bit later. So I'm going to do this across. Let me just show you. It's really the same exact thing, except I'm just not going up and down. I'm going across. So what I'm going to do is this. I'm going to put a fraction for the first one, put a plus, put a fraction for the second one. What's my common denominator? Really quick now, because we've already done this problem. It's 10. Now, what did I do to 2 to get to 10? Multiplied it by 5. So what do I do to the top? Multiply that by 5. What do I get? Negative 15. What did I do to that 5 to get to 10? Multiplied it by 2, multiply the top by 2, and I get 16. You notice it's the same exact problem, isn't it? Except I'm working across instead of up and down. Common denominator is 10. Negative 15 plus 16 is 1. Same exact thing. Okay, this is the way that I want you to start doing it because of what we're going to do later on. All right, I think it's going to be a lot better than working up and down. Up and down is more of a middle school way of doing it. When you start getting into high school and start to get into your algebra stuff, we're going to do it across like this. It shouldn't be too much different, right? Shouldn't be that big of a deal. All right, let's do another one. Let's do 30. All right, so we've got 7/4 minus. Now they put the 1/2 in parentheses. Let's do it. Let's just put it in parentheses. Okay, we're going to do that. Exactly right. This is a subtraction problem. Okay, we're going to add the opposite. So we add the opposite of negative is positive. So now we turn a minus problem, a subtraction problem, into an addition problem, correct? So let's just write it real neat without all the parentheses and the pluses and all that. We'll put a plus right here, and then 1/2. All right, so put this, put this. Now look at my denominators. I got 4 and 2, right? So what number does 4 divide into evenly and 2 also divides evenly? You could put 8, all right? You could, but what do you think that means? I'm not going to do it, right? Okay, I'm not going to make it at 8. There's something smaller, okay? It's called the least common multiple. Do you remember that, LCM? Yeah, the least common multiple. I got a 4 and I got a 2. What do both of those divide into evenly? What's the smallest number? And K-Re 8 is correct. It does go into it. But 4 doesn't divide into 2. So what number, why does it keep doing that? Okay, what number right here does 4 divide into and 2 divide into evenly? It's the only thing I could think of. Only way I could think of explaining it. A 4, that's right. Because what's 4 divided by 4? Okay, it's 1. I'm sorry, it should be the other way. What is this 4 divided by this 4? It's 1. What's this 4 divided by this 2? It's 2. They divide evenly then, don't they? You see that? So you take your new denominator and you see if both of these divides into it evenly. Yep, 4 divided by 4, it's a 1. 4 divided by 2 is a 2. So yeah, 4 is the common denominator. So what did I do to that 4 to get to 4? Yeah, multiplied by 1. Exactly right. Okay. Most people say, well, I didn't do anything different. And you're right. Okay, both ways would be right. You didn't really do anything to that 4 to get to the 4. So you don't do anything to the top. So what's this going to be? A 7. Now, you did something to this 2, though. What did you multiply that 2 by in order to get 4? You multiplied it by 2. So if you multiply the bottom by 2, what? Multiply the top by 2. Because it's a 1, right? 2 over 2 is a 1. What's 1 times 2? It's 2. All right. Now, what's our common denominator? 4. Add them up. 7 plus 2 is 9. There's your answer right there. Don't change that into a mixed number. Okay, there's no reason to change it to a mixed number unless they tell you. I probably will never tell you to change that to a mixed number. Well, I don't know. There's a couple times where I might, but that's good right there. Don't change it to a decimal. No reason to change that to a decimal. Just leave it like that. You can do one more? 31? Okay. So it's negative 1/5. Now, normally, the reason they put these in parentheses, the ones they put in parentheses are usually the ones with the negative, okay? And then this is plus 7/4. That's why they do that. But you don't really need the parentheses if you don't want to. If you wanted to write it like this, that's perfectly fine. But in this book anyway, or not book, but the worksheet, people, whoever made these worksheets, they put all the negatives, they always put in parentheses for the most part. All right, so here, what do we got to do? I set it up like this. Okay, I put my 2 parentheses, I put a plus in between. Now I got to find a common denominator. I got 5 and 4. Yeah, I go 5 times 4, which is what? 20. So a 20 here and a 20 here. Because that's the smallest number that 5 divides into and 4 divides into. 20 divided by 4, 20 divided by 5, 20 divided by 4. Yeah, they divide evenly, don't they? Now, what do we do to that 5? What do we multiply it by to get 20? Multiply it by a 4. So what do we do to the top? Multiply that by 4. What's negative 1 times 4? It's negative 4. Now, what do we do to that 4 to get to 20? Multiplied it by 5. So we multiply what? Oops, why did I put square root? What in the world? Times 5. And then there's a plus, and that's 35. Okay? That's it. So we just put a 20, because that's our common denominator, and then you just add these up. Negative 4 plus 35. They're different signs, so what do? We subtract, take the sign of the bigger one. 35 minus 4 is 31. 35 is the positive. It's the bigger number, so that stays positive. And we just leave it like that. We good? All right. Okay, so I'm going to stop this one. We're going to make a new one, all right? And we'll do the multiplication division. Like I said, it'll probably take us 5 minutes to do the multiplication division.